In this lesson, we're going to learn about the different types of graphs that are associated with our frequency distributions from the previous lesson. Our first graph is a histogram. A histogram is a bar graph created from a frequency distribution in which the horizontal axis displays classes and the vertical axis Using our frequency distribution for the drive-through service times for the fast food restaurant in the last lesson, we can create this bar chart. This graph is a histogram created from our frequency distribution for the McDonald's drive-through lunch service times. The heights of the bars show the different values in each one of the classes. The classes are actually along the horizontal axis down here, or the x-axis. Those are the very same classes we used. And then the frequency along the vertical axis, or the y-axis. This graph was created using Google. Usually our histograms have the bars actually touching each other, and that's indicative of the fact that there should be no gaps in our frequency distribution. But for Google, unfortunately, changing the widths of the bars is not an option. You do have that option in Excel. So know that if you create in Google, I know and you know, we can't adjust the bar width, at least right now. Maybe they'll update it and fix it in the future, or maybe there's a hack that I'm just not aware of yet. So we'll accept this for our histogram. I'll jump down to another histogram created in Excel as a comparison. So here's a histogram created in Excel. This one is a relative frequency histogram, but the idea is that there are no gaps between the bars. They are touching. This is really what is expected for a histogram to look like. A frequency polygon is a line graph instead of a bar graph. And the frequency polygon's line graph, it uses segments to connect points above class midpoints whose height indicates frequencies. To show you what this would look like if we had a histogram, I will draw it on top of the histogram. So the height indicates the frequency. On top of the histogram, we're going to put the dots right in the middle of the bars. And then the line segments connecting these dots. And for a frequency polygon, the line graph is anchored to the x-axis on both sides. Some textbooks will actually label the midpoint instead of the classes. For me, honestly, I don't really have a preference as long as the x-axis has labels that are associated with the data. Midpoints, the classes, then class boundaries. Ultimately, it doesn't matter for the purpose of our class. To show you one graphed out, I have one here for the ages of U.S. presidents at inauguration. Remember that for the U.S. presidents, we did a relative frequency distribution as well. So this is a relative frequency polygon, but the features are still present. You can see that it's anchored on that horizontal axis, both at the beginning and at the end, and the points are right over the class labels, and they indicate the heights. The only thing about this graph that would be different from an actual frequency polygon would be the labels over here. These would indicate the frequencies instead of the relative frequencies. So for a true frequency polygon, the labels would be labeled with the frequencies instead of the relative frequencies. So we might have a slightly different y-axis, vertical axis, but the shape of the graph would be exactly the same. For an ogive, always a fun one to say, ogive. For an ogive, this is a line graph that represents cumulative frequencies for the classes in a frequency distribution. So the ogive is the only one that is specifically for cumulative frequencies. The frequency polygon and the histogram are for the grouped frequency distribution charts themselves. So we would just take the charts as they are, create a histogram, or create a frequency polygon. For the ogive, we have to create a cumulative frequency distribution to graph the ogive. To give you an example of the ogive, here are those drive-through service times again. We have it anchored at the beginning on the x-axis, on that horizontal axis. Notice the labels are cumulative frequency class labels, less thans. So this less than 82, 82 is the lowest lower class limit in our set of classes. So less than 82, there are none of them, which is why we have it anchored. And then these values represent the frequency distribution itself. And we can see that there are 5 classes there, so they correspond to the 5 classes in our cumulative frequency distribution. And then just like the line graph for the frequency polygon, the same thing happens here with the ogive, except it's representing cumulative frequencies. When you have cumulative frequencies like this, your graph will always go up. It will look like if you are a person walking on the graph from left to right, you are always walking uphill on a cumulative frequency graph on the ogive. You are always walking uphill on an ogive. It is not anchored in the far side. It just stops at the 100% or whatever our total number in the data set is. For a relative frequency graph, any of the graphs above can be relative frequency graphs if we use percentages instead of raw data as frequencies. We'll be doing a lot of these examples throughout. And so even though this one's already shown, here it is again. We have a relative frequency histogram. Our classes are along the bottom. Percentages are on our vertical axis, and the bars represent the heights of the percentages. And so you can see 20% here, looks like 51%, 20% again, so forth. Also, popping back up with the frequency polygon, this is a relative frequency polygon. We could create a relative cumulative frequency ogive, changing that cumulative frequency into a relative cumulative frequency, and we'll take a look at these all in some examples. A procedure for constructing graphs, we'll talk about a procedure to do it by hand, and I will show you both how to do it by hand and how to do it using technology. So the graphs that I showed you just a few seconds ago, I have additional lessons where we are creating those graphs in Google and in Excel. We use the McDonald's drive-through data for Google, and we use the ages of the presidents for Excel. Again, just showing the different ways, the different steps used to create either one of them. So the first step, if we're doing it by hand, though technology makes things really easy and really beautiful, sometimes we need a quick sketch. Sometimes we need to do it by hand. So we would first draw and label our axes. And remember that these statistical graphs are already coming from the frequency distribution or the relative frequency distribution or the cumulative frequency distribution. We already have the table set up. We're just drawing the graph from that table. We want to label the classes on the x-axis. I'll write down what we would do by hand, but know that technology, we may not have that option. It might just be easier to use the classes as they are instead of using the boundaries or the midpoints. So for the x-axis, in general, we would label class boundaries of the frequency distribution. For the histogram and the ogive, and label midpoints for the frequency polygon. And I'm going to write a little note here on the side. This may not be possible with technology. Usually with technology, we just use the classes. Google and Excel have a really hard time labeling the bar graphs here in the cracks between the bars instead of labeling the bars themselves. So Google and Excel both like to label the bars themselves. Some statistical textbooks tell you you should have the class boundaries instead. Me personally, I don't think it matters that much. As long as your graph is clear and legible and easy to understand. So for me, more important than which label you put on your graph is that your labels are clear and understandable, like they are here. That you also have axis labels so that people reading your graph understand what each thing means. And that there's a title so that someone reading your graph understands what this graph is representing. That to me is way more important than whether you should use the class limits or the class boundaries. I will say this is my own personal preference. Other instructors may tell you differently. Just know that that second step, labeling that x-axis, it may not be the case with technology that you can label in that way. The midpoints for the frequency polygon is easier, so that is something that we could do. So we'll look at how to do that using technology. And then the last step, plot the frequencies for each class. We'll draw vertical bars for the histogram and lines for the frequency polygon and the ogive. In the next part of this lesson, we'll talk about the shape of the data and how we can identify what shape of the graph we have.